We're always looking at the best ways to educate, aren't we? It's fascinating how priorities shift. Back in the 80s, that A Nation at Risk report really sparked a move toward academic excellence,
Yeah, and it's interesting. The assumption then was kind of, well, if we focus on excellence, equity will just sort of happen naturally. Raise the standard, everyone benefits equally, right?
which brings us to a really key question, especially for subjects like math and science. Did that push for excellence actually lead to true sex equity? Because some research even then suggested it was still elusive for girls in STEM.
Exactly. Elusive. And to really get into that, we've got a great source for you today. It's a 1989 paper, Sex Equity in Mathematics and Science Education, Research Policy Links by Jacobs and Wigfield. It's like a snapshot from that era.
Right. So our mission here is to pull out the key insights from this research. What did they actually find about sex equity back then? How was the research being used or maybe not used in policy? And, what challenges are still relevant for you today?
And it really makes you ask, how well do we really understand the ongoing challenges here? This deep dive should give you a clear picture of the research back then and why this whole conversation, well, it's still so important.
Okay, so let's unpack this. The researchers grouped the research they reviewed into three main buckets. It gives us a good framework.
Yeah, three categories. First, person-centered research. That's basically looking at the students and teachers themselves, individual characteristics and interactions.
Okay.
Then instructional context research. That's more about the classroom environment, materials, teaching methods, that sort of thing.
Got it. And the third.
And finally, macro-level demographics. Looking at the bigger picture course enrollment patterns, career trends, things like that.
All right, let's start with person-centered research.
Yeah.
What did they find about inherent differences between boys and girls in math and science?
Well, it's interesting. They looked at biological and performance differences, and the research back then suggested gender only accounted for maybe 1 to 5% of the variance in abilities.
Only 1 to 5%. That's tiny.
Exactly. And the authors really stress that this shouldn't be used to limit career options. Absolutely not.
Yeah, hardly a basis for steering someone away from a whole field.
Yeah.
But okay, what about actual math performance? That's where you hear about gaps.
It was complex. Girls tended to get higher math grades through K-12, but they often scored lower on the SAT math section.
That classic grades versus test scores thing.
Right. And looking closer, like at problem types, boys had maybe a slight edge on reasoning or word problems in high school, but algebra, basic skills, pretty equal. And sometimes girls were actually better at computation.
So definitely not a simple boys are better at math picture. When do these differences even start showing up?
Well, they didn't find systematic differences until around 10th grade. And even then, the differences favoring boys were small.
Yeah, great.
But there was also a study with younger kids, third graders, where girls actually outperformed boys in all areas of math.
Wow, but that changed.
Yeah, that advantage mostly disappeared by 6th grade. One idea was maybe earlier development of automaticity in girls, processing info quickly, might explain the early computation edge.
Fascinating. Okay, so that's math. What about science performance? Similar patterns.
In science, it seemed mostly linked to course-taking differences. Girls were more often in biology, less in physics. Chemistry was kind of closing the gap.
But overall, course enrollment was different.
Yeah, overall, girls took fewer science courses. One study found 74% of boys took the full high school science sequence, but only 56% of girls did.
That's a pretty big difference. And they thought math skills might be related.
Yeah, the researchers suggested that differences in math skills could be a factor in both science performance and course selection.
Okay, moving beyond student performance, this person-centered research also looked at teachers, right? Potential biases.
Oh, definitely. This part's really eye-opening. Research suggested teachers might hold stereotypes. One study even found teachers gave higher marks to identical science papers if they thought a boy wrote it.
Wait, identical work, just changing the perceived name led to different grades.
Exactly, identical work. The papers attributed to boys got higher ratings for ideas, interest, accuracy, organization, pretty much everything except neatness. Girls got higher marks for neatness.
Oh, that's dark.
And teachers also apparently believed science education was just more important for boys.
That's rough. And it wasn't just grading, right? Teacher interactions, too.
Right. Studies found in some math and science classes, boys got more teaching time, more encouragement, more precise feedback. Especially high-ability boys, more interaction, more praise.
And what's the potential downstream effect of that?
Well, one researcher, Fenema, suggested it might lead boys to develop more independence, more complex thinking strategies in math. Similar patterns in science, too, more teacher interaction with boys. And interestingly, this was strongest with female teachers.
But it wasn't every teacher, right? Important caveat.
Crucial point. Not universal. But even beyond direct differential treatment, there were subtle things. How tasks were assigned, forming teams based on gender, the examples used.
Little things that constantly reinforce gender.
Yeah, one study counted elementary kids being classified by gender about 20 times a day.
20 times. That has to have an impact.
For sure. And even if a teacher tried to treat everyone equally, boys and girls might interpret that treatment differently.
That makes sense. The research also mentioned role models and mentors.
Yes. Studies suggested exposure to female role models teachers, women in STEM jobs could boost girls' participation, mentors too, offering that more personal support. But the paper noted there wasn't much long-term data on how effective mentoring really was back then.
Okay. And the last bit in this person-centered category was self-efficacy. What's that about?
Self-efficacy is basically your belief in your ability to succeed at something specific like math. The research showed a strong link between math self-efficacy and choosing science majors in college, especially for women.
So if girls didn't believe they could do the math,
They were less likely to pursue science, yeah. It seemed to mediate between gender, actual performance, and college math choices. Another study highlighted how much your intended major in high school math courses influence your eventual college major.
so belief in yourself, shaped by experiences and messages, is critical. Okay, let's shift to category 2, instructional context research, the learning environment itself.
Right. This looked at how things in the classroom could create inequities, like sex-biased materials, textbooks showing mostly men in science. Research found this could actually increase sex-typed attitudes, especially in younger kids.
And make girls less interested in math and science.
Exactly. It reinforces that subtle message, this is for boys. One researcher, Kelly, noted globally seeing more males in science roles, classes, teaching, textbooks. It's pervasive.
It wasn't just textbooks, but testing too. Educational tests could be biased.
Yeah, research found bias in test items that used examples from traditionally male experiences. Girls often performed less well on these.
Oh,
And the worry was if girls consistently score lower on standardized tests because of this bias, it hurts their confidence and might lead them to drop math when they get the choice. So the assessment tools themselves could be barriers.
that's a really critical point for you to consider, the measurement tool itself creating inequity. What about how info was presented?
Big factor. A project in England showed if teachers chose topics interesting to both girls and boys, girls' interest in science went up. Their views became less stereotyped, too. So tailoring the curriculum matters.
Makes sense. Connect the material, capture their interest. What about the classroom climate competition? Grouping.
Also revealing, some teachers used competition between boys and girls or segregated them for activities. Research suggested this could actually hurt girls' motivation in math.
Really? Competition hurt motivation.
For girls in math, yeah. Studies found girls had better attitudes in classrooms with less competition, less social comparison, more cooperation, and teachers seen as fairer. Cooperation seemed particularly helpful for girls' math performance.
So, collaboration over competition, at least for girls in math back then.
Seems like it. Research also suggested girls might need more active encouragement, and using mixed-sex, equal-status cooperative groups was proposed to reduce stereotypes. But interestingly, if seating was segregated, teachers tended to gravitate towards the boys' side. More interaction there.
That accidental difference in attention adds up, you can imagine.
Yeah.
Okay, last piece of instructional context. School transitions. Middle school, junior high.
Yeah, this was seen as a really vulnerable time, especially for girls. Early adolescence is when gender role awareness ramps up, pressure to conform.
Right when they're making course choices.
Exactly. Girls often hit puberty earlier, might feel pressure to be feminine just as they face choices about masculine subjects like math. Studies found girls' attitudes to math dipped in junior high. Links between puberty, dating interest, and lower self-esteem or achievement motivation. Even the perception that smart science girls weren't attractive. There was also an interaction found between popularity, gender, and grades. Girls prioritizing popularity sometimes had lower grades. And parents' views on math difficulty for daughters were linked to puberty.
So many social pressures converging right there.
Totally. Interestingly, some studies suggested single-sex science classes during that time might actually help girls. The overall point was, maybe the timing of these crucial course choices isn't ideal for girls.
That's a huge amount to consider about the environment. Okay, third category, macro-level demographics. The big picture view.
Yeah, this highlighted some odd discrepancies. Like we mentioned, girls often got higher math grades, but boys scored higher on the SAT math.
That disconnect again.
Yeah. And course enrollment data was mixed. Some national data showed pretty equal enrollment, except maybe in top-level calculus. A big transcript analysis found similar rates of earning lots of math credits.
So looked okay on the surface sometimes.
Kind of. But other studies found a male majority in advanced math overall. And boys were more likely to have taken higher-level math earlier, by junior year.
Ah, okay. Nuances. What about science courses?
Similar story. More boys took 3 years of science. And while girls participated, they tended to cluster in life sciences. Boys were more likely to take both life and physical sciences, like physics.
So differences in the type of science courses.
Exactly. And even state-level data showed gaps. Fewer girls in Algebra II in California, lower overall math enrollment by 11th grade in Michigan. So local variations existed too, even if national averages looked okay sometimes.
Right, so persistent differences in the level and type of courses.
Mhm.
Now, the paper also looked at programs trying to link this research to policy. What did they find there?
Yeah, they explored how all this research, person-centered, instructional context, demographics was being turned into actual interventions at federal, regional, state, district, school levels. Policy happens everywhere, right?
So what did regional efforts look like for you to be aware of?
Regionally, it was often about coordinating services, technical help through sex desegregation centers. Michigan had a planned change model. Use research to find the problem, districts make a plan, implement it, driven by local needs. Usually voluntary, though, based on the district wanting the change.
Makes sense, that local buy-in, state level.
States had models, too. California had a coalition, CCSE, bringing groups together for research-based programs. They focused on getting key people in districts on board. Michigan's Office of Sex Equity had a planning model involving district staff to make changes last beyond state support.
So empowering local districts based on research. What about actions at the district or school level?
This is where researchers felt the findings had maybe the biggest impact. Things like promoting women administrators, thinking strategically about course choice timing and transitions, choosing fair materials, adding non-stereotyped career info, teacher training.
That in-service training sounds key. Any examples for you to consider?
Project Equals in California trained teachers, counselors, admins on differential treatment research, gave them materials, modeled techniques. Sadker and Sadker did similar training, found trained teachers interacted more with all students. There was also a project, PIPA, to help principals lead on equity.
So training educators was a big strategy. What about programs directly for students?
A lot focused on that person-centered and instructional context stuff. Role model programs were common, like Comets in Kansas, bringing in female scientists. Mentoring programs, too, like one in Michigan, pairing capable girls with trained mentors for support in math and science.
And adapting the curriculum itself based on research.
Yes, like the GEIS project in England. They tried making science more appealing by using topics interesting to both genders, linking science to human biology. It seemed to improve students' views.
Okay, so lots of efforts.
Yeah.
But the paper also said there was still a big research policy link problem. Why the gap?
Several reasons. Funding, often inconsistent, lack of coordination between different programs, not enough good evaluations to know what really worked best. That's a big one.
Hard to scale up if you don't know what's effective.
Exactly. And many programs were voluntary, so they didn't reach districts that maybe needed them most. Plus, the researchers felt sex equity just wasn't getting the same priority as excellence in the big education debates back then.
So, systemic issues, lack of priority, hindering progress. The paper then made recommendations to fix this. What did they suggest for policy, starting regionally?
Regionally. More funding, better coordination, systematic program evaluations, and crucially, stricter enforcement of Title IX, the anti-discrimination law.
The stronger enforcement seems basic, right? State level?
States could do a lot.
Yeah.
Increase math, science, computer course requirements to stop girls opting out early, systematically collect enrollment data by gender, check state tests for bias and fix them, and require equity coursework in teacher training.
So setting standards, collecting data, training teachers,
Right.
district and school level recommendations.
Really practical stuff. Think carefully about school transition timing. Choose fair textbooks and tests. Build equity into curriculum decisions. Promote non-traditional careers in counseling. Integrate career info into classes. Address low math self-efficacy. Make the Title IX coordinator role visible and resourced. And use research on teacher interactions in training.
A whole toolkit for the local level.
Yeah.
What about recommendations for researchers themselves? How could they connect better?
Be mindful of policy levels when designing and sharing research. Refine the research on subtle biases. Focus more on demographics and program evaluations. And communicate better, clear summaries, feedback to schools, presentations. Get involved in policy discussions about testing, textbooks. Use existing channels like WEA or AAA's. Maybe even a clearinghouse for equity research.
A clearinghouse. Interesting.
Yeah, and just foster closer collaboration overall between researchers and policymakers. Make it a two-way street.
So researchers needed to be more proactive in translation and collaboration.
Absolutely. The research alone wasn't enough. It needed to be actively bridged to policy and practice.
Yeah. So, bringing it all together for you, what's the main takeaway from this deep dive?
The bottom line from this 1989 paper is, yeah, we knew a lot about the disparities. We even had some good ideas for interventions, but true sex equity in math and science was still hard to achieve. It needed constant attention and much better integration of research into policy at every level. Just aiming for excellence wasn't enough to fix the equity piece.
Which leads us to our final thought for you, the listener. Thinking about all this research from back then, what single change classroom, schools, district policy do you think would make the biggest difference for sex equity in math and science today? And what's the biggest hurdle to making that change happen? It really highlights how individual experiences, teaching practices, and bigger systems are all interconnected, doesn't it?